Okay, these are the notes for section 3.4 on solving exponents and logarithm equations. We have 17 examples, so let's get started. So for the first one, I have 27 to the x equals 9. Now these first few, I'm going to go very fast because they are reviewed from Algebra 2. So what we want to do is we're going to get our bases the same. So can rewrite the 27 as 3 to the third x equals 3 squared. Once our bases are the same, we can cross off our bases, and we get 3 to the x equals 2, x equals 2/3. Okay, so that's equation 1. Let's move on to equation 2. Two to the negative x plus 1 minus 3 equals 13. We're going to isolate the 2 to the negative x plus 1 by moving the negative 3 to the other side. And I get 2 to the negative x plus 1 equals 16. Now we're going to do exactly what we did in the last problem, and we are going to rewrite with the same base. So I get 2 to the negative x plus 1 equals 2 to the 4th. Base is the same. I can rewrite my exponents equal and solve. So I get negative x plus 1 equals 4. Move the 1, I get negative x equals 3, therefore x equals negative 3. Okay? Like I said, I'm going to go quickly through the first of them because, again, they should be review. Number 3. Let me move that down a little bit. Number 3. And that is 3x plus 2 equals natural log of e to the x minus 2. Now one thing you should remember is that when you are doing natural logs, or actually any logs, that if you take a log with its base, in this case the ln and e, they're going to cross themselves out. They cancel each other out because they're inverses. So 3x plus 2 is going to be left with just that exponent of x minus 2. Solve it. Move the x over, I get 2x, and I write a 3. 2x plus 2 equals negative 2. So 2x equals negative 4. X equals negative 2. Okay, so there's number 3. Let's move on to number 4. Number 4 is 2/3 of x equals 81 to 16, over 16. Okay, so on this one, I know that I can break down 81 and 16 into the 2 and the 3, so I'm going to do that. 81 is 3 to the 4th. 16 is 2 to the 4th. Well, if I notice that they both have the same exponent, so I can rewrite it. 2/3 to the x equals 3/2 to the 4th. Now, if you look at your fractions, they are reciprocals of each other. So, if I have a negative exponent, that would cause me to be able to take that reciprocal. So I'm going to make that 4 a negative 4. And then it's going to allow that fraction to flip over so that now both fractions look the same, and those are our bases, so I can cross them out, and then I flip x equals negative 4. Alright, let's continue now with question 5. Let me get a clean slide. Alright. So question 5, ln of x minus the ln of 2 equals 0. First thing I want to do is I want to condense it. So since it's subtraction, I can rewrite this as ln of x divided by 2 equals 0. If you remember correctly, the base of the natural log of ln is e. So there's an e right there. So I'm just going to take e to the 0 power equals x divided by 2. E to the 0 is 1 equals x over 2, so 2 equals x. Okay, that's number 5. Let's move on to number 6. Log of x to the 25th. Oh crap, sorry about that. Hit the page forward button. To the 25th equals 2. Okay, again, we're going to rewrite this back from a log to exponential. Our base is x. So x squared equals 25. Depending on who your Algebra 2 teacher, they might have said we're doing the smiley faces, or we're doing the smiles, or doing swoop. All of them are the same thing. Take the square root of both sides, make it x equals 5 and negative 5. Now if you remember, the base of a log has to be a positive real number. So that would negate the negative 5, so our solution is just x equals 5. Okay, let's go on to 7. Natural log of 2x minus 1 equals 5. Again, remember the base for our natural log is e, so I'm going to do e to the 5th equals a 2x minus 5, so e to the 5th equals 2x minus 1. Solving for x, e to the 5th plus 1 equals 2x, and then just divide by 2. Okay. Again, many of these are the same level that you did last year in Algebra 2. It's just now instead of having just the log logs, you also are going to have the natural logs. But the processes and what you do are exactly the same. Okay, number 8. For e to the 2x equals 40. Alright, so I'm going to divide by 4 to get the e to the 2x by itself. So e to the 2x is going to equal 10. I need to get rid of the e, so the opposite of our e is our natural log, so that's going to help me get rid of it. That's our inverse. So take the ln of e to the 2x on both sides. The ln and the e are going to cancel, and you're left with, oh, I wrote 2x there, I'm sorry. That should be a 10. 2x equals natural log of 10, and divide by 2. The thing to remember is that 2, you could rewrite it as 1/2 ln of 10, or leave it the way it is. Either way is acceptable. You do not want to divide the 2 into the 10. That ln of 10 is a single value that's being divided by 2. It's not 10 divided by 2, and then you take the log. So make sure you understand the difference. Okay, let's move on to 9. Alright. 9 is going to require a little bit more work, but we can still do it. And that is 8 negative 2 minus x equals 431. Alright, so 8 I can break down to be 2 cubed. Okay, however, 431 is a prime number, so we can't break it down. So I need to take the log of both sides. Now by taking the log of 8, that's going to allow me to be able to bring down that exponent, and that's what I need to do. I need to be able to get that x by itself. So I could do either a natural log of 8 on both sides, or I could use log. So I'm going to use log this time. Either one is fine. There's no hard and set rule. There's a lot of different ways to do each of these problems, and you'll get the same result. Move out your exponent. So that exponent goes out in front. Divide by the log of 8 on both sides, and that gives me log of 431 over the log of 8. And then you're going to move the 2 over and divide by a negative. Okay. So this is our result. However, we could kind of rewrite this a little bit to clean it up using change of base, and I'll change a base. It lets us rewrite this fraction here as a log. The base becomes our denominator, which is 8 to the 431. Either one of these answers is acceptable. Talk to your pre-calculus teacher and see which one they want. Okay, let's move on to 10. Nope, let me move that up a little bit. Okay, so for 10 I have this one, which is 6 to the 3x plus 1 equals 5 to the x minus 7. Okay, so this one's a little more complicated. We have two bases that we cannot get to be the same, and we have x's on both sides. So it's going to require us to log both sides. It's going to require us to do some manipulation of moving things around, and we're going to have to factor. Okay? So let's do that. Let's do the log of both sides. And again, you can use log or you can use ln. It doesn't matter. So we're going to log both sides. Yes, some pre-calculus some pre-calculus teachers always want ln, some want log, some don't care. So ask whoever your respective pre-calculus teacher is what's their preference. Okay, move your exponents out in front. Alright, so I'm going to distribute. I get 3x log of 6 plus log of 6 equals x log 5 minus log 7, 7 log, and I've ran out of room. Let me start this whole line over and give myself a little bit more room. X log of 6 plus log of 6 equals x log of 5 minus 7 log of 5. Okay, I'm going to move all my x's to one side. So I'm going to minus the the x log 5 to both sides. Move all the x's to one side and move all the constants to the other. Okay, so I have my x's on one side, and that's the 3x log 6 and the x log 5. I have my constants on the other side, the negative 7 log 5 and the log 6. Now here's where our factoring comes in. We can't combine these terms right now the way they are with our x's. So what we're going to do is we're going to factor out x because it is a GCF, and that becomes 3 log of 6 minus log of 5 equals negative 7 log 5 minus log 6. And now we just divide both sides by 3 log 6 minus the log of 5. And that's going to help us isolate that x value. Okay, so this one's number 10. Our solution is done. It's not pretty. That's okay. And again, remember, because this is an exponential that we started with, we don't have to check our solution. It's only when we start off with a log that we need to check our solutions. Okay, let's move on to number 11. Okay, number 11. This one's not going to take us nearly as long. Alright, so let's get going. And that is 400 over 1 plus e to the negative x equals 350. Okay, I'm going to multiply both sides by 1 plus e to the negative x so that I can get that variable out of the denominator, and that gives me 400 equals 350 times 1 plus e to the negative x. Divide by 350 on both sides. And on the right side, I'm going to be left with 1 plus e to the negative x. On the left side, the 400 over 350 can reduce down to just be 8/7. Minus 1 on both sides. Now 8/7 minus 1. 1 can be rewritten as 7 over 7. That's going to leave me 1 over 7. Equals e to the negative x. We need to get rid of the e so that we can bring that exponent down. So I'm going to do the natural log on both sides. Okay, the e to the ln of e is going to cross off, and I'm left with ln of 1/7 equals negative x. So negative ln of 1/7 equals x. Okay, there's our solution for number 11. Let's move on to number 12. Okay. 12, this one's going to involve some factoring. E to the 2x minus e to the x minus 12 equals 0. Okay, the e to the 2x, that can be actually rewritten as e to the x squared minus e to the x minus 12. Now we can factor it exactly the way it is here, or we can use something called a u sub. All a u sub means is we're going to substitute u for something. In this case, it's going to be that e to the x. And all the u sub allows us to do is make our problem look more familiar to what we're used to. And so that e to the x changes to u squared minus u minus 12 equals 0. Factor it. So it's u minus 4 times u plus 3 equals 0. Now again, you don't have to use the u sub. You can if you can see the factors when it's e to the x, you can go that route. This is just for those of students who want to use it. Solve each one and I get u equals 4 and u equals negative 3. Once you've got the u's solved, you can put the e to the x back. Okay, so on the first one, for e to the x equals 4, e is always a positive number to an exponent. That's always going to give me a positive number. So in my right solution, this one right here, if e is positive and I have it to an exponent, it's never going to equal a negative. So I'm going to cross that one out because that one's an extraneous solution. We can't have it. And now we just solve for the one that's left. So I'm going to do the ln on both sides to be able to eliminate the e, and x equals ln of 4. And that's our solution. Alright, let's move on to 13. 13 involves a little bit of condensing. And that's the log of 4 to the x minus log base 4 of x minus 1 equals 1/2. Okay, so what we're going to do is we're going to condense this first down to a single log. So it's log base 4 of x over x minus 1 equals 1/2. Now we're going to rewrite it back as an exponential, so 4 to the 1/2 power equals x over x minus 1. Well, 4 to the 1/2 power is the same as the square root of 4, and that's 2, equals x over x minus 1. Cross multiply, and I get 2 times x minus 1 equals x, so 2x minus 2 equals x. Move the x's to one side and I get negative 2 equals negative x, so 2 equals x. Again, this is a log problem, so we're going to put it back into our original equation. And if you look, I have log base 4 of 2. 2 is positive, so that first one it works. Again, this is what I'm looking at. The log base 4 is 2. This has to be a positive number. Minus the log base 4 of 2 minus 1. This also has to be a positive number. Alright, and that's what we have. So this is my correct solution. When you start off with a log problem, you have to check your solutions. Okay, let's go to 14. Fourteen's going to take some space, and you're going to need your calculator. So I'll give you a minute to go grab your calculator. Pause the video while you do so. Okay, so hopefully you've grabbed your calculator, and we're on number 14, and I've taken the liberty to write the problem down. The first thing we're going to need to do is we need to condense our log problem here to a single log. And I'm going to say the log base 10 of 4x that's not an x. Let me rewrite this. Over 12 plus the square root of x equals 2. Rewrite it now without the log, so back as an exponent. So it's 10 squared equals 4x over 12 plus the square root of x. Cross multiply. Well, first of all, 10 squared is 100 equals 4x over 12 plus the square root of x. Cross multiply. And I get 1200 plus 100 square root of x equals 4x. What I'm going to do is I'm going to set this equal to 0. So I'm going to move everything to one side. And I'm going to make I'm going to leave the 4x positive, so I'm moving everything over to the right side. Okay. Now you're probably looking at this like, okay, now what do we do? Because I have a square root of x in there. I can't square both sides because of the fact that it would still give me some square roots and it would just be really nasty. And if I had up on the previous step, like a minus sign or something, it would still not be very good. But I know that the middle term here, the square root of x is squared, gives me x. So off the side, so what I'm saying is this: the square root of x squared equals x. So I could rewrite this as 4 square root of x squared minus 100 square root of x minus 1200. So it looks like a quadratic, so in a quadratic form, so we could factor it. Well, another thing I should notice now is that I can divide all my numbers by 4. Okay, because I'm not dividing by a variable, we can do this. So I'm going to divide everything by 4 just to make my numbers a little bit smaller. And my screen's having some issues right now. So give me a second here. Okay. Again, so now we look at factoring. And this doesn't factor. So if it confuses you to have the square root, let's put a u in there for that square root. So let's say the u equals the square root of x. And that gives me x squared, or excuse me, not x squared. U squared minus 25u minus 300 equals 0. And if we have something that doesn't factor, we can do the quadratic formula. So let's do that. U equals the negative of negative 25 plus minus square root negative 25 squared minus 4 times 1 times 300 all divided by 2 times 1. Alright? And that gives me 25 plus or minus the square root. If I simplify everything under my square root, I get 1825 divided by 2. Square root of 100, it was 1,825 is 42.7200. So I'm just going to use the 42.72 divided by 2. What I now have is u equals, I split this up, u is approximately 33.8600 and use approximately negative 8.8600. Replace that square root of x with each of those. I'm going to drop the zeros off, guys. And square root of x equals negative 8.86. Okay, now we got to look at it. Okay, can the square root of x equal 33.86? Yeah, that's a positive number. We can do that. To get rid of that square root, I'm going to square both sides. And I get x equals 1146.4996. And I shouldn't put equals, it's approximately still, because I've done some rounding. Now my second solution, square root of x equals negative 8.86. Square root's a positive, so I can cross this one out. And there's my solution for 14. Alright, let's move on to 15. Alright, 15. So I'll do 15 and 16 on this next slide, and then we'll do 17. And then on that last slide, I'm going to put the word problem all by itself. Okay, so let's do 15. 15 is very similar to, actually both 15 and 16 are very similar to what we did with 12. And we get 3e to the 2x minus 13e to the x plus 4 equals 0. Okay, so now let's break this down. I'm going to use the u sub again, and I'm going to say u is equal to the e of x, and I'm going to say that now I have 3u squared minus 13u plus 4 equals 0. Factored, you get 3u minus 1 and u minus 4. Solve each factor and I get u equals 1/3 and u equals 4. Replace the u's with our e to the x's. And now again, e to the x is has to equal a positive. Okay, in both cases these are positive, so they work. So we're going to have two solutions this time. So do the log on both sides to get rid of the e. ln of e crosses out and I get x is equal to the ln of 1/3. ln of e crosses out again, x equals the ln of 4. Okay, so that was 15, quick and simple. Let's move on to 16. Oh, that's a bad 16. Okay, 16 is e to the 2x plus 2 e to the x plus 1 equals 0. Let's factor it again. Again, we're going to say u is equal to e to the x. So I get u squared plus 2u plus 1 is equal to 0. This factors to be u plus 1 and u plus 1 equals 0. So we have a multiplicity, so we have two of the same factors. So setting it up, so u would equal negative 1. Substitute the e to the x back in. And now I get e to the x equals negative 1. Now because both factors are exactly the same, there was only going to be one value, and that was negative 1. And e to the x can't equal a negative, so I have to cross that out. Therefore, we have no solution. And that's going to happen sometimes. Sometimes you're going to have one solution, 2 solutions, sometimes no solutions. Okay. Now I am actually, now that I think about it, I'm going to throw another problem on here. It's not in your notes, but there's another example that I can think of that I want to just do very quickly. So you can do this on another sheet of paper and add it in here, or you can, if you have space on the back side of another page of notes. So this one's not in your notebook, and I'm just going to call it 16B. Okay? Okay, so it's going to be 5 times 2 to the 2x power plus 7, or excuse me, not plus, I wrote it down wrong, I'm sorry, minus 7 times 2 to the x plus 2 equals 0. Okay. So here's what I'm going to do. I'm still going to use a u sub, but instead of having it as an e to the x this time, I'm going to use 2 to the x, and you might be wondering why I'm using 2 to the x. If I look at my b value, right here, my middle term, it tells me what my smallest exponent is, and that's the x, so, and with my base. So this right here kind of tells me what my my u can be. So u is equal to 2 to the x. And now it becomes very similar to what we did in the previous problem. It becomes 5u squared minus 7u plus 2 equals 0. Factor it, and I get 5u minus 2 and u minus 1. And so, solving each one, I get u is equal to 2/5 and u is equal to 1. Substitute back the 2 to the x in, and I get 2 to the x equals 2/5 and 2 to the x equals 1. So now on the first one, I'm going to do the log of both sides. Move the x down. And then divide. Okay, and remember, we can clean this up a little bit, and I could rewrite this as the log base 2 of 2 to the 5th. Okay, now let's look at the other one. I get 2x plus 1, or 2 to the x equals 1. Well, this is a special. This right here is a special occurrence. And you should realize that any 2 to what power is always going to give you a 1. Think of any value, any positive real number to the 0 power always equals 1. So right there, whenever you see something like this where you have a positive real number to an exponent, that's your variable, equals 1, x is also equal to 0. So you have 2 solutions here. Okay. We hadn't done one like this where we used something other than e to the x, so I wanted to try and give you an example of that. Okay, so now let's move on to 17. That's our last problem. I'm going to write the problem on here, so I'm going to pause it for you and write the word problem on the next slide. Okay, so this word problem is not going to take us that long. It's really quick. It says the number of trees per acre N of a certain species is approximate by the model. N is equal to 68 to the 10 to the negative 0.04x, for 5 is less than equal to x is less than equal to 40, where x is the average diameter of the trees in inches, 3 feet above the ground. Use the model to approximate the trees in a test plot for which n is equal to 21. So all we're going to do is we're going to put the equation, the model they gave us, this one right here, we're going to put that equal to 21, because 21 does fall between 5 and 40. So 21 equals 68 times 10 to the negative 0.04. Okay. Now we just have to solve it. First step is we're going to divide by 68. And you're going to need your calculator for this. And that comes out to be approximately 0.3. Oh, what just happened there? I have no idea what just happened there. Sorry about that. .3088 is equal to 10 to the negative 0.04x. Okay, we need to get the x out of the exponent, so we're going to take the log of both sides. And this time, because it's base 10, we're just going to use LOG. Okay. Again, the log and the 10 are going to cancel. And now I'm left with the log of 0.3088 equals negative 0.04x. Divide that point. So I now have log of 0.3088 divided by negative 0.04 is equal to x. Using your calculator, because it is asking for the approximate, so it's not going to be exact. X is going to be approximately 12.7581 inches. So the average diameter is going to be 12.7581 inches. Okay, so that's the examples for this chapter on logs and exponents. We've done quite a few equations, but we've done lots of different examples so that you can see all the different types. If you have any questions, bring them to class.